One of the most important parts of dealing with data is visualizing data, and that's particularly true of quantitative data. So you need to think about the appropriate methods that you're going to use for displaying this data. Within quantitative data, there are only 3 or 4 different methods. Now, the reason you want to do visualization is you want to be able to identify problems with your data. So one potential problem is you might have more than one peak, so you've got multimodal, which means you've mixed together 2 groups within your data. You might be concerned to see if your data is normally distributed or if it's got skewed to the left or right, so that's the obvious shape to your data. You want to know if there are outliers, some values that are particularly large or small that you don't believe are true, or if something strange has happened. If you plot your data, you might see some kind of pattern that you weren't expecting to see, which suggests that your experimental equipment has gone wrong or your experiment went wrong. So the first set of tools you can use to display your data, or the first thing you should do for continuous data, is a histogram. If you've got discrete data, it would be bar charts. But this case, the bar chart is largely being used like a histogram. It's the most basic way of displaying data. Histogram is for continuous interval data, therefore you don't have any gaps between the bars in your histogram. If you have a uniform width of your histogram bars, then you can use frequency to measure their height. If they have varying widths, then the y-axis should be frequency density. Bar charts are usually for nominal or ordinal data, but they can be used for discrete data, like something like a binomial distribution where height is frequency. So here's the example histogram for the height of 120 students that I happened to put in and enter. Now, as well as the histogram, the other important chart for continuous data is the box plot. Now, in the histogram, you display it like this, you look at it, you look at the shape, and you can tell if it's normally distributed, if it's symmetrical, or if there's any kind of skew in the data. The box plot is another visualization tool that you can use to look about any kind of skew or odd behavior within your data. The middle box is the interquartile range. The white line through the middle is the median. So the median, if it doesn't rest in the middle of the interquartile range, then you've got some kind of asymmetry. Then you have whiskers, which are 1.5 times the interquartile range, and then beyond that you have extremely unusual points which are marked. When you get any set of data, often you can divide it into subgroups. For example, when I've got height data, I can divide it into male and female heights. There are examples of can be confounding variables or your treatment variable. So you'll have the treaty group and the untreated group, and you're measuring whatever it is as your outcome, the thing that you want to measure to see if anything's being changed. That divides your experimental set of data into control and non-control. So once you can divide your data into more than one section, you can do box plots for each of the different groups, each of the different factors. So here is a box plot of height where I'm looking at male heights and female heights. The great thing about the box plot is this can tell you if you're seeing any genuine differences in your data. So in this case, if I look at the median for both the male and female, it sits roughly in the middle of the interquartile range. So now I've separated the data from being just one set of data into 2 separate group sets of data. Now the medians fall in the middle of the interquartile range, whereas when I had them both pulled together, the median was at the bottom end of the interquartile range, where I didn't consider gender. I can also see that the 2 interquartile ranges do not overlap with each other. The whiskers do overlap, but not massively. So this tells me from this set of data that I can assume that there's a difference in height between men and women. So 2 key plots are histograms for checking out the shape of your data, how widely it's spread and if it's normally distributed, and box plots for doing comparisons between groups, and they also give you some indication of their symmetry depending on the symmetry of the whiskers and whether the median sits in the middle of the interquartile range. The other plots that you can do, you do when you have two quantitative variables, two numerical variables you want to compare to one another. In these cases, what you're looking for is an association, so can you use one variable to predict the other? So to do this, you plot a scatter plot. In this case, we've got height plotted against weight. We have females with one labeling, male with another labeling, and also using color to distinguish. And you can see that in general, men are taller and heavier than women who are shorter and lighter. But there's a relationship between height and weight. If you imagine we're a cylinder, as the cylinder gets taller, it weighs heavier because we have the same amount of density. This is not unexpected. That relationship between your two axes is called correlation. It's very important to do a plot before you look at correlation and regression, which is fitting a line to your data. So a perfect correlation means as x goes up, y goes up. A perfect negative correlation means as x goes up, y goes down. A correlation of 0.8 means there's a certain amount of scatter about that line, but you could still see that there's a positive trend that as x goes up, y goes up. But once you get for correlations below 0.5, so this is a minus correlation of 0.3, the scatter is so strong that it's very difficult for you to see that there's a clear line in any direction. In this case, there should be a line which is a correlation of minus 0.3, so there should be a negative trend line, but it's quite difficult to see as correlation decreases. So the three graphs that you should use on quantitative data are histograms, box plots, and if you've got two quantitative variables, scatter plots.